input and low output impedances of a feedback amplifier, the topology used is here series kind of connection. See, first parameter always, that is the parameter towards the output side, and the second is these and this is the first, this is second. So in order to get low input as well as low output impedance, the output must be connected in shunt and the input must be connected in shunt. That is, if we are connecting output in shunt, means we are taking the voltage as we are sampling the voltage at the output side. That is, voltage shunt is the possible topology to get both low input as well as the low output impedances. That is, option D is correct. Into values, we have to find out the ICQ and VCEQ. Beta is given as 100 for the following circuit shown below. So here VB is written as, here VB is 24 divided by 20 into 10 that is, sorry, here VB is going to be 0 because of the exactly opposite and equal potentials. So, and Thevenin's resistance is going to be 5k. So if we model this circuit as, this is 5k minus 12 ohms, 2k plus 12 ohms. So apply the KVL at the input side. 0 is equals to IB into 5 plus VBE, that is 0.7, and 101 IB into 2, and plus this is minus 12. So 12 is equals to 207 IB plus VBE, that is IB is equals to 12 minus 0.7 by 207 milliamps. So ICQ is nothing but beta times, that is 100 times 11.3 divided by 207 milliamps. So VCEQ is equals to 24 minus ICQ 4. So from this, ICQ and VCEQ is given as, here this is nothing but 5.459 milliamps. VCEQ is nothing but, it is, so 5.46 we can take approximately. This is 2.04 volts, that is option D is correct.
Motor air gap power is 10 kilowatt. Okay, he has given PG is equal to 10 kilowatt and mechanically developed power is 8 kilowatt. So PM is equal to 8 kilowatt. Now what are the rotor ohmic losses? We know that rotor ohmic losses, okay, let us take it as PR is equal to S times of PG. Okay, that is slip times of air gap power is equal to rotor ohmic losses. Now what is slip we have to find it. The relation between mechanically developed power and air gap power is PM is equal to 1 minus S times of PG. Okay, PM value is given as 8. So this is 1 minus S times of PG is equal to 10. So 1 minus S is equal to 0.8. Slip is equal to 0.2. So what is rotor ohmic losses here? PR is equal to 0.2 into air gap power, that is 10, which is equal to 2 kilowatt. So option C is the correct answer. Reactance in 6-pulse converter with source inductance is. Now what is 6-pulse converter? That means it is going to have 6 thyristors. Okay, that is 3-phase 6-pulse converter. Okay, this 6-pulse converter is having source inductance. Okay, if this is having source inductance, AC source, Generally, this is a three-phase circuit, so there will be three lines going to this ABC leg. Okay, now what is the output voltage across the load? The output voltage across the load is given as V0. Let us take it as, okay, this V0 is equal to 3 root 6 pi into V phase cos alpha. Okay, because of this source inductance, what happens? There will be drop in this output voltage, that is equal to 3 times of omega ls by pi into I0. Okay, this we can represent it as, this is the AC to DC converter rectifier. So this is 3 root 6 pi into cos alpha into V phase. Okay, drop across this one is 3 times of omega ls by pi. Okay, let us take, this is going to have a load. Okay, current flowing through this one is I0. This 3 omega ls by pi is known as commutation reactance. Because of this, what is going to happen? There will be overlap angle mu. Okay, it depends upon the value of source inductance ls. So for 3-phase 6-pulse converter, the drop is, that is commutation reactance is 3 times of omega ls by pi ohms. Option B is the correct answer. Phase full bridge inverter has DC input of 800 volts, then what is the peak value of output AC voltage? Okay, for single phase full bridge inverter, now let us take the input voltage is VDC. Now what is the output waveform here? The output waveform will be a square waveform, okay, having the value equal to DC input value. Now what is the peak value here? Peak value is nothing but a DC value, which is equal to here 800 volts, which is given as an input. So option D is the correct answer. Cycloconverter is used to obtain a variable frequency single phase AC output. That means he is converting three phase frequency to single phase AC output. The single phase AC load is 220 volts 60 amperes at a power factor of 0.6 lagging. Now what is the RMS value required at the input side? Okay, he is asking RMS value of input voltage per phase. Okay, now for three-phase cycloconverter, what is V0? V0 is equal to V phase times of, this is 3 by pi into sine pi by 3. Generally for M phase, it is expressed as V phase into M by pi into sine pi by 3, pi by M. Okay, since we are having 3 phase M equal to 3, the equation is represented like this. Now, what is the AC output voltage we have here? AC output voltage is equal to 220 volts 60 amperes at a power factor of 0.6 lagging. Okay, this is the required AC load. Now, what is V phase here? I can write V phase is equal to V0 by, okay, this is 3 by pi into sine pi by 3. Now what is V0? V0 is given as 220 volts. Since it is single phase supply, 220 volts is given as an RMS value, okay, into 3 by pi divided by sine pi by 3 is sine 60, that is root 3 by 2. You will get it as 266.02 volts. That is option C is the correct answer. This is equal to s plus 1 by s plus 2. We have to find initial value of f of s. Okay. Now, what is f of s here? I can divide this one as s plus 2 minus 1 by s plus 2. So this is equal to 1 by 1 plus 1 by s plus 2. Okay, 1 minus 1 by s plus 2. Now what is f of t? F of t is equal to delta of t minus e power minus t. Okay, to find initial value of f of s, that means limit t tends to 0, f of t is equal to, okay, it is having limit t tends to 0, delta of t minus e power minus t. Okay, when you go through the initial value theorem derivation, okay, initial value theorem is not valid for impulse functions. Okay, here f of t contains impulse functions. Since initial value theorem is not valid for impulse functions, the initial value cannot be determined is the answer, option